All right, hello everybody. It is time for us to go over the lesson 1-7 worksheet. This one's a little bit different because for proofs, there are different ways to write proofs that are still correct. So if you have a different proof than mine or different reasons than mine, that could be okay. So don't freak out if you're looking at this and going, but I wrote it differently or I put it in a different order. A lot of times it'll still work out. All right, that said, I will show you what I wrote. So for number 9, fill in the missing reasons for the proof of theorem 1-4. This theorem, we don't really need to know what it is from our notes because it shows us right here. The theorem just tells us if two angles are right angles, then the angles are congruent. And that's all that's shown right here. So that doesn't really matter that we know the number of the theorem. So we'll start with our proof. Angle F and angle G are right angles. That is given, of course. Then the measure of angle F equals 90 and the measure of angle G equals 90. So I'm thinking to myself, well, when angles are right angles, how do I connect them being right angles and them being 90 degrees? Oh, it's in the definition of right angles. A right angle is a 90-degree angle. So my reason is going to be the definition of right angles. Okay. Number 3, the measure of angle F is equal to the measure of angle G. Well, if I know that they're both equal to 90, I can just take the measure of angle G from here and move it up to there and substitute it in. So I'm using substitution. Substitution. And number 4, angle F is congruent to angle G. And so if we know the measures of the angles are congruent, how do we know the angles are congruent? We know that because that's the definition of congruent, right? We know that equal measures equals congruent. So that's the definition of congruent angles. All right. Number 10, error analysis. A student uses the vertical angles theorem and the definition of complementary angles to conclude that the measure of angle PTR equals 50 in the figure. What mistake did the student make? So here's PTR. Notice that that's this angle down here. That's the big angle. So we're going to work through the problem because, of course, we can't immediately see what happened. So let's work through it and figure that out. So if we start out with our vertical angles, we know that x plus 28 is equal to 2x plus 16. And then we can go ahead and solve this equation. So subtract x from both sides. So 28 equals x plus 16. Then, of course, subtract 16 from both sides. Subtract 16 from both sides. And we get 12 equals x. So x is equal to 12. So then we have to figure out what the measure of angle PTR is. So we can plug it into one of our two angles that we know. So if we plug it into angle QTP, that's going to be 12 plus 28, right? And that's, of course, going to equal 40. So we know that this angle is 40 degrees, which also means the angle across from it is 40 degrees. And so to find the measure of angle PTR, that's a linear pair. That makes a 180-degree angle. So we can do 180 minus 40 and get 140 degrees. So that's what the measure of angle PTR actually is. So we have to think, what is the mistake that the student made? Well, if we had 50, if they said it was 50 and this one was 40, it looks like they used 90. They used complementary angles instead of 180 for supplementary angles. So their mistake was they used complementary angles instead of supplementary. There you go. Number 12, write a 2-column proof of theorem 1-6. And then it tells us theorem 1-6. It says, given that ABC and CBD are a linear pair, prove that ABC and CBD are supplementary. So let's make the framework here for our 2-column proof. Oh, that's going to bug me. Hold on. Let's try again with a straight line. There we go. And statements and reasons this way. And reasons. And of course, they start out by giving us the first statement, right? Given that angle ABC and angle CBD are a linear pair. So step 1 is that angle ABC and angle CBD are a linear pair. Right, that's given. We know that. We should all have the same first step. Then we say, all right, we're trying to prove that ABC and CBD are supplementary then. So I'm trying to think, what do I know about linear pairs? I know linear pairs happen when we have 2 angles that together make a straight line, right? Together they make a straight angle. So if I put these 2 angles together, I would get angle ABD. And so I know, and again, I could be skipping some steps here. I could make this a longer proof, but I'm going to go into what I would think logically could be a next thing we could say, which would be that the measure of angle ABD is equal to 180 degrees. And I know that because my first step said that they were a linear pair. And I know that by the definition of linear pair, that's 2 angles that together make 180 degrees. So that's the definition of linear pair. All right, and then step 3, we're on to this one. If we know that the measure of angle ABD is 180, we also know that the measure of angle ABC and the measure of angle CBD, then, these 2 angles that make it up, have to add to 180 because that's these 2 angles together to get angle ABD. So the measure of angle ABC plus the measure of angle CBD equals 180. And so for number 3, we say, well, how do we know that? We know that because when we add 2 smaller angles, we get a bigger angle. That's called the angle addition postulate. The angle addition postulate. All right, on to number 4. So if I know that, I miswrote this last step. I shouldn't have said equals 180. I should have said equals something else. Let me put this line back here. They should equal the measure of angle ABD. That's what the angle addition postulate says. That means that the 2 smaller angles together equal the bigger angle. So then we can write in step 4 that equals 180. We can write that the measure of angle ABC plus the measure of angle CBD equals 180. And in this case, we are using substitution to know that because we know the measure of angle ABD is 180. And so we're going to substitute 180 where we wrote the measure of angle ABD last time. So we're using substitution there. And finally, if I know that these 2 angles together equal 180, that is the definition of supplementary. So I'm trying to prove that these are 2 supplementary angles, so I can go ahead and say that we now know that angle ABC and angle CBD are supplementary, right? And we ask ourselves, what's the connection between two angles being added together to be 180 degrees and two angles being supplementary. That's the definition of supplementary angles. So the definition of supplementary. And of course, if you had your answer in a different order, that's fine. I think I probably could have switched steps 2 and 3 without too much trouble there. And I could have said different things as well. There's not just one proof that will work. All right. Number 13, explain how the congruent complements theorem applies to the figure shown. And we see that we have two right angles that are sort of overlapping each other here. Got one right angle there and one right angle here, and they're kind of overlapping. So what that means is this angle in the middle, angle WZX, that's complementary to the angle on the left, and it's complementary to the angle on the right, because we know that that's part of the right angle on the left, and we know that it's part of the right angle on the right. All right, and since this angle is complementary to both of these angles, the congruent complements theorem then would tell us that angle VZW is congruent to angle XZY. That's that congruent complements theorem in action. So let's write that out. We can say angle WZX is complementary to both angle VZW and angle XZY. And since it's complementary to both angles, since it is complementary to both angles, then angle VZW is congruent to angle XZY. That's how that theorem applies here. Number 16, pretty simple. Find the value of each variable, the measure of each labeled angle. So we're just going to set these equal to each other. We've got 3x minus 47 equals 2x plus 8. And then, of course, we can go ahead and solve. So subtract 2x from each side. That's going to give us x minus 47 equals 8. Add 47 to both sides. It's going to be x equals 55. So that's part of our answer. It says find the value of the variable. So that's here. And then we also have to find the measure of each labeled angle. So we have to go in, plug this into one of those angles. It doesn't matter which one because they're vertical. So if I write 2x plus 8, that's the same thing as 2 times 55 plus 8. And that's going to give us 110 plus 8, or 118 degrees. So both those labeled angles are 118 degrees. Once again, this program is not going to recognize my rectangle as a rectangle because I'm so bad at using the Apple Pencil. There we go. All right. Next, 25. Given angle ABC and angle DEF are supplementary, so angle ABC is supplementary to DEF, and angle ABC is supplementary to GHG. So the same angle is supplementary to both those angles. What can you conclude about the angles? We can use the congruent supplement theorem and say if the same angle is supplementary to both angles, then this angle and this angle must be the same. So the measures must be the same, right? The measure of angle DEF is equal to the measure of angle GHJ. Number 18, write a paragraph proof. All right, paragraph proofs are a little interesting because they are all different. So it depends on what you want to write. And as long as your work makes sense logically, as long as it flows and as long as everything that you've written has a reason included for it, then you should be fine with your paragraph proof. So we're given this information. The measure of angle ABC is equal to 114 degrees. The measure of angle DHE is equal to 25 degrees. EHF is equal to 41 degrees. And we know that angle ABC and angle GHF are supplementary. So the big angle over on the left and this angle right here add up to 180. We want to prove that angle DHF, this one right here, is congruent to angle GHF. So that's a lot to think about, but let me think about where to start here. Let's try and figure out what these two angles are all together, right? We would just add them. When we're adding, we're using the angle addition postulate. So I can say by the angle addition postulate, I know that the measure of angle DHF, those two angles added together, is equal to 25 plus 41, which is 66 degrees. So I know that this whole thing is 66, okay? And I also know that ABC and GHF are supplementary, okay? So I can say that I also know that 114 plus 66 is 180. And since I know that, since 114 plus 66 equals 180, I know that angle ABC is supplementary to angle DHF, the one I've been looking at. Now I have angle ABC on the left being supplementary to both angles. Angle DHF I just showed, and angle GHF is supplementary in the given information. And if one angle is supplementary to both other angles, those angles must be congruent to one another. So since angle GHF is also supplementary to angle ABC, then I know the angles are congruent. So then angle DHF is equal to, or congruent to rather, angle GHF by, what did we call that? That's the congruent supplements theorem. By the congruent, I'm just going to use shorthand there, the congruent supplements theorem. All right. Number 21, the graph shows percentages of sales made by various divisions of a company in 1 year. What are the angles formed by the segments for each division? What are the missing percentages? Explain how you were able to determine each percentage. All right, so let's find the percentages first, since we already have percents, and then we can go into finding angles. I know that a pie chart has 100% in it, right? That'd be the whole thing. And if the pie chart has 100%, then half the pie chart would be 50% of the pie chart. So if over here, this side is 50% of the pie chart, and I have 23% here and 18% here, then I can do 50% minus 23% minus 18%, and I find that this division C area is 9% of the total. And I can do the same thing over here for division E. If I know that this side of my pie chart has 50% in it, I can do 50 minus 27 minus 13, and I get 10. So I know that division E has 10% in it. So now that I've got my percentages, I want to go ahead and find the actual angles. And that's where I'm going to use the number of degrees in a circle, which of course is 360 degrees. So for each of these numbers, I'm going to do the same calculation. I'm going to do the the percentage. So we'll start with division A, and I'll say, it's 27%, so it's 0.27 of the whole thing, multiplied by the number of degrees in a whole circle, 360. So 0.27 times 360 degrees is going to give us the angle of division A, which is going to be 97.2 degrees. And we're going to do the same thing for the rest of the divisions. We're just going to take the decimal and multiply it by 360 degrees. So we'll take division B and we'll do the same thing with all these. So 0.23 times 350 is going to be 82.8 degrees. Division C is going to be 32.4 degrees. Division D is going to be 64.8 degrees. Division E is going to be 36 degrees. And division F is going to be 46.8 degrees. All right. Number 19, write a 2-column proof for each statement. This is a long video. I'm sorry about that. So we're given angle 1 and angle 2 are complementary. We have the measure of angle 1, and we want to prove that the measure of angle 3 is equal to 113. So let's make our T-chart here. There we go. So we've got our statements. And our reasons. And we'll start with number 1. Number 1 is easy because it gave it to us. It said angle 1 and angle 2 are complementary. And angle 2 are complementary. Okay, and that's given. And there was another piece of given information that we can use as our second statement, that the measure of angle 1 is equal to 23 degrees. So that was also given. Then let's keep going. What do we have to work with? We have complementary to work with. What do we know about complementary? We know that complementary means two angles that add to 90 degrees. So we can use that as a statement. We can say, since we know that angle 1 and angle 2 are complementary, we know that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And we know that because of the definition of complementary that tells us that. The definition of complementary. Number 4 then, if I know the measure of angle 1 plus the measure of angle 2 is 90, but I know that the measure of angle 1 is 23, I can substitute in 23. I can say 23 plus the measure of angle 2 equals 90 degrees. So I know by substitution that that's true. Substitution. All right, so then let's keep going. We can say step 5. I have an equation here, and I have an equation where I can subtract 23 from both sides. And if I subtract 23 from both sides, I'm left with the measure of angle 2 equals 67 degrees, right? I know that by subtraction. All right, awesome. Let's see, I can go back up to the diagram. I say if I know that the measure of angle 1, I can write that in, it's 23. And I know that the measure of angle 2 is 67. Hey, I have a linear pair right here. Okay, So I'm going to use my linear pairs theorem to tell me that. I'm going to say that angle 2 and angle 3 are a linear pair. And I know that because look at them, right? Looking at them, they make a line. So that would be the linear pairs theorem. No, it wouldn't be. It would be the definition of linear pair. I'm so sorry. The definition of linear pair. Right? And what do we know about linear pairs? We know that when we add them together, we get 180. So when we can say the measure of angle 2 plus the measure of angle 3 equals 180. That is the linear pairs theorem. So linear pairs theorem. And then if we take measure of angle 2, we know that. We know that from step 5. The measure of angle 2 is 67. So I can substitute that in there and say 67 plus the measure of angle 3 equals 180. That would be substitution. And you can probably see where this is going, because finally I can subtract 67 from both sides and say that the measure of angle 3 is equal to 113, and that is by subtraction. That is a lot, I know. There's certain steps in here that you might be able to get rid of, like step 6 you might be able to get rid of. You could maybe combine steps 3 and 4 together. So there are a lot of ways to write a proof and make it still be a proof. Don't worry too much if yours doesn't completely match mine. We just have to make sure that every statement has a reason that connects one statement to the next, right? Why is this statement connected to the next one? Because of substitution. Why is statement 5 connected to statement 6? Because it's the definition of a linear pair, and so on and so forth. So we need to make sure everything is connected to each other. And then finally, number 24, classify each of the following statements as always true, sometimes true, or never true. Measure of angle 1 plus 4 is equal to 180. Well, they are a linear pair, so that is always true. The measure of angle 1 plus 2 plus 3 is going to never be 180. That's going to be more than that. The measure of angle 2 plus the measure of angle 4, they are going to be congruent, but there's nothing to say that they cannot also equal 180, right? If this one's 90 and this one's 90, it's 180. So that's sometimes going to be true. The measure of angle 2 is equal to the measure of angle 3, or angle 2 is congruent to angle 3. Again, if they were both 90, that might happen, so that could be sometimes true. 2 and 4 are vertical angles, so I know that angle 2 is always congruent to angle 4. And then finally, the measure of angle 3 is congruent to the measure of angle 4. Again, they're a linear pair, so that's sometimes true when they're both 90. All right, whew, that was a lot. Thank you for bearing with me with that. Hopefully you got some questions answered. If you do have any more questions, let me know, and have a wonderful day.